Hello everybody. I often get asked by final year project students, what is this thing about this critical data analysis that we are required to do in our projects? So I thought I'd do a quick tutorial the way I see it. But of course, you would really need to discuss that with your project supervisor if they are on the same page with me in terms of data analysis. So you are required to do a critical analysis of a question or several questions, and I thought I'll do a little example. So let's assume, just for sake argument, our topic is we want to investigate diagnostic tools for brain rot disease, where your brain goes into total meltdown and becomes mushy and all these things. And of course, this is a wide topic, and we need to break it down into easy, researchable questions that we can very easily address. So ideally, in the morning, you wake up with an idea, with a question that you want to ask, and by the end of that day, you have an answer to this question. So that is what I mean by we need an easy set of questions. So if we want to investigate if there are diagnostic tools for brain rot disease, we can break that down, for example, into can we find a good biomarker for brain rot disease? Let's call this biomarker, maybe we call it XYZ or whatever. And because that would be a really good diagnostic tool if we had this biomarker. But then the next question is actually, what makes a good biomarker? A good biomarker, obviously, would be something that allows us to test various people, maybe around the world, and get immediately or after some experiments, get a readout where it says, yes, the biomarker is high and therefore the person is likely to develop brain rot disease. And then the next step would be, well, if we want to check whether this is applicable to lots and lots of people, we would then ask the question, is there potentially a difference between the serum level of potential biomarker when we are looking at people from different countries? So that would be here really the low-level question that we can easily address. How would we go about addressing this question? Well, we have already specified we are looking at this biomarker and we are looking at people from different countries. So we would put something into a search engine like PubMed, and here our search criteria would be we are looking for, let's say, serum levels, the biomarker of interest, let's say XYZ, and we just put in some countries, let's say Germany, and we compare them with Australia. So these would be the search criteria, and that would be a part for the material and methods, because you want to tell your audience what were you looking for. And you can also then say, what did I not look for? So for example, serum levels of I don't know, modified XYZ across the USA or something like that. So this is the part that you describe in your material and methods section. So you put that into, let's say, PubMed, and lo and behold, you get some results from PubMed. And you find a paper by Smith and Williams where they measured actually the serum levels of XYZ, and they found that they are elevated in sleep-deprived children in Germany. Okay, so the study was conducted in Germany, and they reported that the serum levels of this biomarker in normal individuals, that means not the sleep-deprived individuals, were found to be 145 microgram per liter, and they give a standard deviation and also the sample size. So this is the German group. Now you also come across a paper by Atkins and Johnson, 2018, where it actually looks like has no similarity to paper 1. They are looking at preeclampsia and hypertension, but from the abstract and from the keywords, you find that this study was conducted in Australia. They are also looking at the level of biomarker XYZ in a completely different context, but again, they have normal individuals, so healthy individuals, which are not affected, and they find a mean value of 123 microgram per liter, standard deviation, and they also have a sample size. So what we now can do is we can compare these numbers because they are both coming from healthy individuals. They are looking at our biomarker we are interested in, but they are from different countries. And now we can address this question. Actually, is there a difference in the serum level of this biomarker when we look at people from different countries? Because the only difference really are the geographical locations. So how would we then analyze that? Well, we are aware that the data are probably continuous data. They are not count frequencies when we look at the means. So continuous data can very nicely be analyzed with a t-test, where we actually formulate the null hypothesis. So H null in this case would be there is no difference. There is no difference between the population means, and the only difference that we observe is due to sampling error. So only difference due to sampling error. Because we do see a difference in the samples due to sampling error. Okay, so how can we deal with that? I usually go for a really convenient online calculator, and you can put that into Google search GraphPad Ttest. This is a really good calculator, and usually with me it comes up as the first thing in my search. So Ttest calculator, GraphPad. So here is this test calculator, and because what we have been given is the sample means, and we've got the standard deviation, and we've got n, we would click on this box here, enter mean, standard deviation, and the sample size n, and we have different forms of t-tests. Now, in our case, we don't know really if the variances of the populations are the same. And therefore, the correct test is this one here. That's the Welch t-test. That's an unpaired t-test with specific modifications when the sample sizes and the standard deviation or variances of the samples are not the same. My advice would be always go for Welch test, because an unpaired t-test is just simply not a very good tool. And it says here used rarely, I would cancel that. I always use the Welch test. So all we need to do now is put in the data. So paper 1, we had 145 mean, 10 standard deviation and 50 individuals. Paper 2, 123, 20 and 38. And we calculate our results. So press the calculate button. And here we get our summary. So the Welch t-test result. So first of all, we get a p-value. Here, this p-value is less than 0.0001. And we know that if p is low, if p is much smaller than our significance level alpha, which very often is set to 5%, if p is low, h naught must go. So we reject the null hypothesis, and we can say that obviously there is a statistically significant difference between the two samples. Since they are coming from healthy individuals, there is something else that makes these samples very different. So in this case, it's probably the location. And we also get, for example, some important information, and I've highlighted here some of the information that we need. So t equals 6.216. That is the t value that has been calculated, and this df, that's the degree of freedom that has been calculated for this Welch t-test. So what are we going to do with these data? We need to report them in a proper way, and here is from this website here. Here is how we report the t-test. So in our case, here we would report the independent t-test, the results of the independent t-test, and this would actually look like something like serum levels of XYZ in 38, that's our N, healthy Australian individuals, that's our mean that we had from the paper, 132 microgram per liter. Standard deviation 20 microgram per liter were significantly different from the serum levels in 50 healthy German subjects, and again we have that. And then here is this report that we are going to use. So here this is the degree of freedom, and this is the t value, and here we spell out the p-value. So the p-value in this case is smaller than 0.0001, which means we reject the null hypothesis. And therefore we can make the conclusion from this result. I can, for example, write this. From this result, it can be concluded that the serum levels of biomarker XYZ show statistically significant differences in various populations, if we compare Germany with Australia. And if we go back to the original question, are they basically the serum levels in healthy individuals suitable for measurements across the world? We can say no, they are not suitable, and therefore biomarker XYZ cannot be used as a universal indicator for brain rot disease. So with this approach, we have very nicely, swiftly answered one of the questions: is biomarker XYZ really a good diagnostic tool? So I hope this shows you how you actually carry out a critical analysis, which steps you can take in order to come to a meaningful conclusion. I hope this makes sense, and thank you for watching.